On this next page of 4.3, we will be looking at specifically the expanding the logarithm properties. And the first three examples are to get us a little more familiar with the power rule specifically. So it says use the power rule to help expand. And so we're going to see that in all three of these. So notice the first one, log of something to a power. So right now, before we get distracted by that product on the inside, the first thing we need to do is resolve this power. So our property from the previous page says this 5 can come out front. So we can have 5 times log of 4x. And now that it's simply a log of a product, now we can break that apart. Now when you break this apart, this 5 is in front of this log. So you can do it in 2 steps like I'm going to do here. That 5 has to be in front of both the logs you get when you expand this, meaning the log of 4 plus log of x, right? Breaking that product into the separate logarithms combined through addition, but that 5 is in front of both of them because that's all technically what that represents, right? That guy right there represents all that, so we need 5 times that. And so as a final step, we could distribute that 5 to make sure he's in front of each of those logarithms individually. Okay, and that's it. That would be, there's no simplifying there because these are involving a variable. No approximating, I should say. All right, next one. Log of 32 to the x plus 2. So first thing we'll do is take that exponent and pull it out front. Now when it's out front, I'm going to need parentheses around it because it's one thing that just got pulled out front of log of 32. And now, think of log of 32 as a number, a thing, outside of x plus 2, so we can essentially distribute each of those to it. So we're going to have x times log of 32 plus 2 times log of 32. And again, being that there's a variable in here, we're not going to bother approximating at all. So that's our final answer. And now, the last one here, we got to talk about the square root. We've seen it on occasion here, and talking about exponents especially. When we see a radical, we want to remember there is an exponential way to represent the radical. This is a square root. So the very first thing I'm going to do is remind myself that this square root of x is the same as x to the 1/2 power. Be familiar with the fractional exponents and their correlation to powers and roots. That allows me to then take that 1/2 as a power out front and have that be 1/2 ln of x. And that's actually all we can do here. So there's a couple examples of our power rule and how we can use it. So now we look at a couple more just expansions, right? Expanding each expression as much as possible. So first one, we have an ln of a product of multiple things. So we can break that apart. Ln of e to the 4th plus ln x squared plus ln of z, right? Breaking each product apart into the additions. Now, there's 2 things we can do here. This part, this term, ln of e to the 4th, this is actually one of our rules, one of our other properties from before. Remember, ln is log base e. And in fact, I'll just write our line here to remind you of this. ln represents log base e. And we have log base e of e to the 4th. We have where the bases match. So this whole term is actually nothing but a 4. So again, this is where you want to watch for as you're expanding these especially. Watch for those first 4 properties on the previous page for things like this that you can actually do something with in terms of simplifying. Now, the next one, all we can do is use the power rule to pull the 2 out front. That is considered part of the expansion process, is pulling the exponents out front with power rules. And ln of z, there's nothing to do there. And so that expression would be our final answer. And then the next one here. All right, first and foremost, the biggest thing we see is a quotient rule. So I would start with that. We can rewrite that as log, base 6 of the cube root of x minus log base 6 of 36y to the 4th. Right, just breaking apart division into subtraction. Now again, I'll go ahead and use that understanding that the cubed root would be a 1/3 power. So I'll do that. Now, here, we've got a minus sign in front of a logarithm that we're about to break apart because this is multiple things, 36 times y to the fourth. I'm going to go ahead and use parentheses to help me remember I was subtracting this logarithm, so I need to be subtracting the logarithms I get, log base 6 of 36 plus log base 6 of y to the fourth when I separate them, right? That's me breaking apart the product into an addition. The minus sign has to be in front of all of that. We'll see why that's important in a minute. Now back to here, this is where I can use the power rule and pull the 1/3 out front, 1/3 log base 6 of x. I'm going to go ahead and distribute this minus sign through these parentheses, but also as I do it, I want to point out what we've got here, log base 6 of 36, okay? Let me go ahead and just write this much. As I distribute this minus sign, log base 6 of 36 is log base 6, and if we can recognize 36 as a power of 6, that's 6 squared. We'll come back to that. Over here, I'm distributing the minus sign, minus, and you could do this all in one step if you wanted to. But I'll actually wait. We do have a power rule up there. So let me just focus on distributing the minus sign and rewriting that 36 as a power of 6, because now I can come through. There's nothing left to do on that term, but log base 6 of 6 to the second is another example of that bases matching rule. This whole expression turns into a 2. And then this expression, log base 6 of y to the fourth, just another power rule, bringing the 4 out front for log base 6 of y. I know that doesn't look like a very nice final answer, but the idea is we're just working on understanding our rules for expansion and for seeing these certain logarithmic terms that we know very much how to simplify them.